Hello and welcome to another video tutorial from Microcubic, where we will take a look at the measurement annotations. Let's get started. You can place a crosshair at the center of the camera preview for easier alignment. As a side note, right-clicking on the camera preview automatically centers the clicked position using the motorized stage. Please note that the scale bar must be activated for this function, but it works whether or not the crosshair is in use. The next feature is the circular measurement. Here, you can adjust the center and diameter of the circle by moving the blue dots. Please note that the circular measurements are accurate for top-down imaging and not trigonometrically corrected for tilted imaging. As a side note, all measurement annotations illustrated here can be used for both Lens 1 and Lens 2, provided that they are calibrated and the correct data is selected from the bottom left scale bar drop-down menu. The other annotation feature is angle measurement, which displays the angle between two lines based solely on pixel calculations. You can also use this feature for simple contact angle measurements. You can move the camera to its 90-degree position, adjust the viewing height using both primary and secondary tilting axis, and measure the static contact angle of a droplet. For more precise measurements, we recommend capturing a photo of the droplet and processing it using a third-party software, like ImageJ or Fiji with a contact angle measurement plugin. Now, I'd like to move on to the next three annotations, including tilted height and width measurements. Please pay close attention to the distinctions between these three modes. You can use the 2D rectangle annotation during top-down imaging, which occurs when the tilt angle is close to 0. However, for larger tilt angles, while the horizontal axis of the rectangle will still provide the correct value, the vertical axis will be inaccurate due to the apparent view of the image caused by tilting. To address this issue, we have introduced a new annotation for tilted width measurements. In this case, the apparent pixel value is divided by the cosine of the tilt angle to display the trigonometrically corrected value. Let's check this using an actual microfluidic chip. The 2D rectangle is used for top-down measurements along both the lateral and vertical axes. After tilting, we can still use the rectangle for lateral measurements. However, we need to use the 3D width annotation for the vertical axis, which measures the channel width. Similarly, to measure the height or depth of a channel, we now have a separate annotation whose value is corrected by the sine of the tilt angle. Note that these measurements assume the sample is flat and the channel walls are vertical. If you have any doubts, you can always align the sample with the horizontal axis and measure without needing any correction for the tilt. Let's now measure another sample using the high zoom lens, a microfluidic chip fabricated on a silicium wafer. As a side note, this lens does not have an integrated infrared filter, so you may need to adjust the white balance depending on the ambient lighting. Otherwise, you may notice a purple tint. For highly reflective samples like silicium, you need to be especially cautious when measuring height or depth, as the sidewalls may appear twice as large due to reflection. Here, we have a photoresist channel that was previously measured at 15 micrometers using a stylus profilometer. We will align the 3D height annotation to the midpoint, where the interface with the silicium surface can barely be seen as a thin line. As in the previous example, you can use the width annotation to measure the channel's width in this tilted view. Please always remember that measurements are accurate only in focused regions and depend on the accuracy of your calibration data. Regarding focusing, I want to mention that the software does not yet support live measurements after focus stacking. Finally, the software allows you to capture two versions of the image, one with annotations and one without, so that the original image can be utilized later with annotations in your own style. This feature is enabled by default, but you can disable it from the settings menu if desired. Please remember to check the calibration of your lenses, especially before critical measurements. We have a dedicated video tutorial on this, and feel free to reach out to us whenever you need support. We hope you enjoy using your microscope. We're continuously working on new features and always appreciate your feedback and suggestions. Don't hesitate to contact us for support or to explore customized projects. Thank you for watching and goodbye.